Next on the tour is a bunch of other string types. And we have a str, string, borrowed str, and so there's two types, but there's actually some others if you want. There's something called CString, there's something called CStr, OsString, and OsStr. And this is if you need to interact with different types of strings. This is obviously a string that the C language can work with, and OS is operating system. So this will be for because strings in Rust are all guaranteed UTF-8, and sometimes converting into sometimes they'll be different, and you don't want to just pass a regular Rust string if you're working directly with the operating system. So there, an OS string is something you can make, and you can see, here's the need for it. So Unix systems, they are arbitrary sequences of non-zero bytes, sometimes UTF-8. Windows, they are sometimes UTF-16, whereas Rust, they are UTF-8, which may contain zeros. That's not you don't need to know that, but if you want to make strings for this situation, then that's what you this is what you use. And I found this into string signature really interesting, because it's a result, and we've seen results all the time. It might fail, so it's a result. But if you take an OS string and you try to convert it into a Rust string, if it works, then you get a string, and if it's an error, it's actually just going to give you the OS string again. So it's not going to make an error and blow up. It's actually going to just give it back to you, basically. So it's kind of interesting that way. And that's what my one example there is for. And by the way, FFI, FFI means foreign function interface. And whenever you see FFI, it just means working with other languages. So let's use this quick example. Let's see, OsString, and we are going to, of course, you can just say OsString, and we can just say OsString from. So it's really easy to make, and it's not going to fail. So you can say this string works for your OS too. So that gives us an OS string, and then let's match string into string. And most of the time it's going to work. It's kind of hard to think of an example that is not going to work. So I decided that I would just do this instead. Here's one way to see what it's going to produce. So not valid. If it's an error, we're going to get the string back. So we'll have some sort of string anyway. And so how are we going to show that this is a regular string and this is an OS string? And the way we do that, of course, is we call a method that doesn't exist, and then we get the compiler angry, and then see what it says. So if we run that, then you can see it is giving back an OS string here. So on the second part here, it's saying, hey, I don't have a method for for OS string. So that's what it's given us. Whereas here it's successful, and it's given us a string. So that's how that works. And there's and you can see it has all the regular shrink with capacity, push, all those stringy vecchi looking methods that we saw. And that's about all we're going to look at for this, because these are the types of strings that you don't need until you need them, and then when you need them, you will have like an actual reason to do it, and then you'll be looking through the methods yourself. But just remember that there's also the str type as well, and it'll represent a borrowed string, and it's the CStr, the CString is full of these unsafe methods, and Actually, yeah, this is a good time to introduce unsafe. So whenever you're using FFI and there's no guarantee that Rust can make that this is safe, like this is now doing a whole bunch of C stuff, and we're beyond Rust guarantees. Then if you want to use this, you have to use this unsafe block and say, okay, this is not completely guaranteed, but I'm taking care of it. And by the way, unsafe is it's good because it keeps people cautious, but it's also it's kind of like instead of unsafe, the feel behind unsafe is I got this, bro. It's kind of like that feeling. So it's the programmer saying that I've checked that this is safe, and so please trust me and just do what I'm asking you to do. And that's what gives Rust the ability to do all this deep systems programming, because sometimes you'll just maybe you have like an embedded device and it says you have a little device and you want to make it blink, and it says to make it blink send something to this memory location, and Rust is not able to guarantee that that it's safe, but that it is because it's in the manual, and that's how you make it work. So then you have this this little unsafe block, and these unsafe blocks are also good because if you're doing work FFI work with C or whatever, and then you have like an error in your code, then the first place you can look is the unsafe blocks, because they're going to be as small as possible. There's not much unsafe blocks in Rust overall. Even when places working with C a lot, it's still the unsafe blocks are pretty small in number, and so you can start debugging from there. So that is a bit of a foreign function interface, and you'll use it if you need it.